Hello, welcome back to Auto Guide Math Class, a platform where you get a solution to your mathematics problems in all topics. In this video, I shall be looking at a sword as a topic. A sword as a topic. The topic for today will be sword. Sword is a topic we use in approximation of irrational numbers. So it's a topic that approximates irrational number. How do we simplify those numbers that are irrationals? So before we proceed on sword, at the end of this video, you should be able to simplify sword, to perform some operation of sword, maybe addition, multiplication of sword, then division of sword, and sometimes equation that involve sword. How do we solve them? Then also we can also use sword to find some square root of number. How do we find square root of number that involve sword? So those are the subtopic under sword that I will walk you through in this video. So then the first thing to consider here is, as I have it on the slide, the first slide is we should consider of rational number and irrational number. What is the difference? A number that can be expressed in form of ratio P over Q. They can be expressed in ratio where P and Q belong to the set of integers. When it says set of integers, I mean they can be positive or negative whole numbers. It can be either positive or a negative whole numbers. That's what it means by set of integers. So this integer are both positive and negative whole number. Then such that Q will not be equals to 0. Because if Q is equal to 0, and you have P over 0, so it's going to give you what? Infinite number. That means it's undeterminable. So Q must not be equal to 0. When it says something are rational numbers are rational, they are either positive or negative whole number. That's one of them. They are integers, which we can define as both positive and negative whole numbers. Even if they are fraction, the fraction we are terminating fraction, terminating decimal fraction. That means the digit of decimal terminates, or they have recurring decimal numbers. So that's, for example, if I have 1 over 4, it's a fraction and the decimal terminates, which is 0.25. Let's say 3 over 4 is also 0.75. You see, the digit terminates, it has end. So it's either the fraction, the decimal number has end, that means terminate, or the decimal, if it did not terminate, the decimal is the decimal are recurring. They are recurring. It has a recurring decimal. That means the decimal will not terminate, but it will be repeating. The decimal are repeating. So when you have a repeating or recurring decimal number or a terminating decimal, we said such a fraction are still what? Are still rational numbers. They are rational numbers. All right. Now, irrational numbers are numbers that cannot be expressed in ratio of P over Q, in ratio, so that PQ belong to set of integer. So we cannot express them in that form. And another factor irrational number also have is that their decimal number neither terminates nor recurring. So one of the example of fraction that behave like that is pi. So pi is, let's say, 22 over 7. That's approximately to be 22 over 7. All right. And what? The decimal, it has infinite decimal digit. Infinite decimal digit. I mean, the decimal has no end. And the decimal are not also what? They are not recurring. it's not repeating. So the decimal has no end. That's one of the factors. And also the decimal is not reoccurring. If it is not if it has no end and it is reoccurring, it will become what? A rational number. But the decimal are not reoccurring. They are not reoccurring. So you continue to have different digits of decimal number until what? Till infinity. Such a number, they are what? They are irrational. Another example is what? Exponent. Exponent value, which will give you, this one will give you 3.147, as one different type of number, digit of one. So we give you 2.17. If you press it, let's, for example, let's use our calculator to get. So you continue to see infinite decimal number. For example, if I have 22 divided by 7, right? That's is. So let me express it in the. So you have a lot of digits that are what? That has no end. That has no end. Look at it. It has no end. See, this one the calculator can accommodate 1, 2, 3, 4, 5, 6, 7, 8, 9. So this one the calculator can accommodate. So if the calculator can accommodate more digits of this number, you see that the digits will continue to what? To span through the calculator, and it has no end. So another one value is exponent. The exponent. That means this. This second function, this shift, then this. Sorry. Second function. Right. So let me say exponent 1. Exponent 1, that means this. So you have 2.71, 82, 81, 828, right? So you have 2.71, you see that the numbers are not recurring, the digits are not recurring, 2.71, 82, 81, 82, something like that. Also on continuously see what the calculator can accommodate. So this is one of the, so why I'm putting e raised to the power of 1, because that's the e raised to the power 1 is the same thing as e. So that's how so we have e raised to the power. This number, they are what? They are irrational numbers. But another form of irrational number, they are all the square root of let's say prime numbers, root 2, root 3, and so on. All those numbers, irrational numbers which are root of rational number, are called so. Irrational numbers, example of irrational numbers, they are the root of prime numbers. Let's say root of prime numbers, they are irrational behavior. Root of prime numbers like root 2, root 3, root 5, root 7. Even if I have another root, let's say root 15. Root 15 is not a prime number. 15 is not a prime number, but it can be broken into two prime number. Let's say 3 times 5. You see, root 3 times root 5. You see how it's broken into two prime number, and those prime numbers, when you express them, they are what? They are irrational in behavior. So we also have, if I have root 10, even those numbers that are not can be broken into what? 2 times what? 5. And this 2 times 5 will be broken as root 2 times root 5. Right? So root 2 and root 5, they are what? They are prime numbers. So that's why any root of prime number, or any number, even if it's odd number, that can be broken into what? A prime numbers, all these numbers become an irrational numbers. Now, surd in its the word surd now is irrational number which are root of rational numbers are called surd. Irrational numbers which are root of rational numbers are called surd. That means surd involve root, any expression that involve root of numbers, maybe in form of this one root of b, or maybe root of a plus a whole number, let's say b. So any expression that has root of this, even if that root is a prime numbers, I mean the number there is prime number or odd number, so far it can be what can be expressed in this one, it become irrational. So how irrational is form of surd is form of a way of approximating irrational numbers. So then rules of surd, there are some rules that guide surd to simplify surd. One of the rules is, if I have a square root of, if I have a number, it can be broken into a multiple of two numbers in this form. So if if I have a surd, let's say root 18, I can be broken into two numbers, two multiple of root 2 of 18, which is 9 times 2. And the idea is that one of the multiple must be the highest perfect square that you can break that number into. So the highest perfect square in that something that is the highest multiple of that perfect square will give you what will be helpful. So because this root 18 can also be broken into 6 times 3, but none of these multiple is a perfect square. So you have to target one of the multiple to be perfect square. If I have 6 times 3, it cannot reduce this number, because neither of them, either 6 nor 3, is a multiple of what? Is a perfect square. So this cannot reduce it. So you have to look for the two multiple that one of them is a perfect square, so that this one can be reduced to what? Root 9 times root 2. And if you can now find this one, to give you what? 3 root 2. So this is how to use it to simplify surd. Another rules of factor is that if I have a surd with only once under root and is dividing, it can be broken into root a over root b. I mean, root a over b is the same thing as what? Root a over root b. That's another one. Then the third rule is that the square root of a minus or plus or minus, whether it is plus that is there or minus that is there over b, is not equals to this. So you cannot break surd, let's say 5 plus 6, and you now break it into root 5 plus root 6. This one is not allowed in surd. It's not allowed in surd. So these are the simple rule under surd. And the next slide is simplify the following surd. To simplify the following surd, like I said, you break the number into two multiple of that number that is product will give you the number. They give you 45, but one of them must be a perfect square. If I have 45 can be splitted or has a multiple of 15 times 3, but neither 15 nor 3 is perfect square. So I can also split it to 9 times 5. So you look for another one that one of them must be perfect square. And you see 9 times 5 perfect square instead of using 15 times 3. So because neither 15 nor 3 is a perfect square. So this one will give me root 9 times what? Root 5. So this will now be 3 root 5. So this is how to break it to this. Then root 162 can be expressed as 81 times 2. If you don't know what to do when you see a number, just find the factor first. So 162, some of you have a problem of identifying. How will I know what is the multiple that will be perfect? So since you are targeting a perfect square, you should be able to know your perfect square. The perfect square are 1, 4, 9, 16, 25, 36, and so on. Those numbers that they multiply themselves, the result they have is what? The two number multiply itself, the two natural number multiply itself, the result you have is what? The perfect square. So this you now take 2. What 2 type? 2 can go in this one. 2 in this, I have 81. Right? And 81 is identified to be perfect square. So I can now say 2, the answer is 2 times 81. So this will now be root 81 times what? Root 2. So this will be 9 root 2 together. So also root 75 can be broken to 25 times 3. 25 times 3 will give you 75. And this one can be broken into 25 times root 3. And I will have 5 root 3. So also root 200. 200 can be 100 times 2. You see, all these are perfect square, perfect square, perfect square, perfect square, right? That will help you to reduce the number, because the focus is you want to reduce the number, you want to reduce the surd, you want to simplify it. So this is, we give you root 100 times root 2, and this one will be 10 root 2. And we also have root 288. 288 can be reduced, can have a multiple of which one of them targeting is what? 144. So 144 times 2. 144 times 2 will give me 288. So this one can be splitted into root 144 times root 2. Right? And root 144 is 12 root 2. Alright. Also on. Now root 98. Root 98 say the same thing. Root 98 we have if you don't know what to do, 98, see, so 98, I have 98. What can go in 98? 2 can go. 2 in 98 to give me 4. Remember that one, that's 9. You see, and 49 is the perfect square. So I will have this 49 times 2. If you are thinking of what, all you just need to know is to be able to identify your perfect square. So, and split into how the number into which one of them is going to give you a perfect square. So this is 7 root 49 root what? Root 2. That's one. So what do you think this one will be? Root 147. So we will also give you root 147. So I don't know what 147 will give me. I will come here, I will write 147, just one corner of your paper. So what number that can go? Can 2 go in 147? No. Then try 3. Can 3 go in 147? Yeah, 3 can go in this one. Then I have 4. Remember 2 in 27 to give me 9. So that means it is 3 times 49. So this one is 49 times 3. This is how to check if you don't know the multiple. So this one will give me root 49 times root 3. And root 49 is 7 root 3. Also on. So the last one is root 99. Root 99 is the same thing as 9 times 11, right? So that one is easy. So this is root 9 times root 11, and root 9 is 3, and root 11 is a prime number. So this is how you simplify surd. And this one is the reverse of that surd. What if you have a simplified surd and they want you to write it as, said, express the following as a square root of a single number. The square root of a single number, that means you want this. What you apply here is this. When you have a root b and you want this a to enter the umbrella of this root, so this a will carry a square. That means times b, right? So this is the method you apply in all of them. So like this one will become 2 squared times 3. And 2 squared times 3 give me root 4 times 3. And root 4 times 3 will give me root 12. So on. Here, the same thing. So you put your root. Since the whole number want to enter under the umbrella of that to be 3 squared, then times 5. So this one become 9 times 5. And you have root 45. It's very easy. So this say roots. Then this whole number 5 want to enter the root, it will carry a square. That means you put a square, then times 2 that is there before, then this one becomes 25 times 2, and you have root 50. And so on, right? So this 4 want to enter, so it will have 4 square times 6. So 4 square times 6 give you 4 square is 16, then times 6, then you multiply. So it will multiply so it will give you 16, that's 6 times 6, that's 36, carry 3, and that's 96, or so on. Then this is 3 square times 10, and 3 square is 9, times 10, will give me 900, and this one will give me 900. You see? So this is just the reverse of the first one. So this will be, when the 5 want to enter the square, it will carry a square, times 7, and you have 25 times 7, and 25 times 7 will be 175. 175, right? So 175. So also on, that's how to reverse something that you can also simplify this one back to the simplest surd. All right. Then the next slide is operation with surd. How do we simplify? How do we operate using operation? We talk of operation, we mean addition, subtraction, multiplication, and division. So the first in this slide we talk about how do we add or subtract surd? Addition of surd, we add surd based on factors that are alike. So the surd must be alike. So like this one, you see that something is common to them, which is root 2 here, root 2 here, and we have 4 of root 2. We have 6 of that root 2. If we have 4 root 2, just like 4 orange, 6 orange, 4 orange plus 6 orange, you give me 10 orange, 10 oranges. So 4 oranges, 6 oranges, give me 10 oranges. That 4 root 2, 6 root 2, you give me 10 root 2. Or you can write 4 plus 6, something is common, which is root 2 is common to them, right? It's root 2. So this one will give me 10 root 2, right? In factor. So this same thing here, root 7 is common, factor it, that's 3 minus 8, then you put what? Root 7, right? 3 minus 8 to give me minus 5 root 7, right? It's in terms of 7. Or you just do it like 3 root 7 minus 8 root 7. I mean, the negative is more than the positive, so it's going to be negative. The answer is going to be negative by after you have subtracted it. That's minus 5 root 7. Now also, but there are other one where you need to simplify. This one, they are simple because already simplified before you have to add. You're just to add that we prepare for you. Just come and add them, just come and add them. That's already in a simplified form. But what if they are not simplified? So you have to use our previous knowledge of simplification of surd, reduce them first to see when they will now have the same surd, then you now collect those ones that are alike. So something is that you need to be able to simplify and then be able to collect like them, those ones that are similar, that have the same surd, then you put them together. So for this one, so our knowledge of simplification will come in, that's 3, then root, let's see 8 times 8 can be splitted into 4 times 2. That's a multiple of 4 times 2, then plus, then 50 can be splitted to 25 times 2. Now, with this one, you see that we have 3, then times root 4 times root 2, plus this one will be root 25 times root 2. You see, this root 4 is 2 times 3, I have 6 root 2, plus root 25 is 5, then root 2. You see, root 2 and root 2 is common, so I can factor it, or you can say 6 root 2 plus 6 plus 2 to give me, so just give me 11 root 2. Or if you like, you can factor it, if you like, you can factor it the way you want to do. You can say, okay, if I like, you can say, since say 6 plus 5, then root 2. Then I will now write the answer as 11 root 2. Anyone you like, method you like, it's the same thing. So the same thing is also applicable to this one. This one is already simplified. 3 root 2. Root 2 is already as called as, this is just the minimum root that you can get for this one. But what of 18? It's not the minimum. So we have 3 root 2. Then this one, root 18 can be splitted to what? To 9 times 2. You see, 18 can be 6 times 3, which will give up 18. But none of this one is useful. They are not work, cannot reduce them. This 6, neither 6 nor 3, it's perfect square. It's not a perfect square, so it cannot help you. So the only one that can reduce it is when you use 9 and what? And 2, because 9 is a perfect square, right? So please don't use something that cannot reduce it. The multiple, you must target a perfect square. We have many multiple of some numbers, but you look for the one that has a perfect square that will be able to reduce your value. So this one will be 3 root 2, then minus square root of 9 is 3, then root 2. So 3 root 2 minus 3 root 2 is going to give me 0. So the answer there is 0. So that is all for that. Then the next slide is more question on this. This question, there are more question on this, so that I will just be solved like one. Okay, let's see this one. So we have root 20 plus root 45 plus root 125 minus 2 root 80. You have to simplify this. So root 20, just simplify it one by one until you see a factor or maybe common root that you can use, or common sort that you can use to collect like term and simplify it. So this one can be broken to 4 times 5. Yes. So we can't say 10 times 2 because 10 and 2, none of them is perfect square. And we can't say, so the only one that has the perfect square that can give you 20 is 4 times 5. 4 times 5, so that 4 is a perfect square. So please, that's what you should target. Then plus, then this here we have 45. 45 can be 15 times 3. 15 times 3, none of them is perfect square, so I cannot use that one. So we think of another factor that is something that can multiply to give you 45, which is what? 9 times 5. Then also this one, 125, I have 25 times 5. 25 times 5. Now with this one now, you are thinking right, she will already be what? Seeing that there are some factor that is common. So this is what? Also 16 times 5. 80. 80, 16 times 5. So you can't say 20 times 4. 20 times 4, even if it is, if you say 20 times 4, it means 20 can still be broken further. So look for the highest perfect square in that multiple. So like I said, if you use, it's not that if you use if I use root this one, I say 80 is the same thing as 20 times 4, right? 20 times 4, we broke this one into 2 root what? Root 20. But 20 can still be broken further. 20 can still be broken to 2 root what? Root 4 times 5 again. Right? So that this one will still be what? Broken into this. And I have 2 here. Then it will now give me, finally it will now give me 4 root 5. So that's what I'm talking about. That is, this 20 times this. So this. So root 4 is 2, then we still have root 20, and you can still break this one into another perfect square. So that's why I said it is better to get the highest perfect square in that one, which is what? Use the multiple that will give you the highest perfect square, which is 16. So in this, I have, I can reduce this one to, since, look at it, the perfect square here is 4 square, 4 square. So the square root of 4 give me 2 root 5. Then plus, this one is to be give me 3 root 5. Plus, this one give me 5 root 5. Then minus, this one will give me 4. 4 times 2, give me 8 root 5. So 8 root 5, 2 root 5, 8 for all 5 is common. So I can collect like that means plus 3, plus 5, minus 8. Everything root 5 is common to them. So I have factorized root 5 out. So because root 5 is common to all of them. So I can now add my value. 2 times this one, this will give me 5, plus 5, that's 10, 10 minus 8. Answer will be 2 root 5. So this is how to simplify it. Let's look at this one also. So this one says 2 root 135 minus 2 root 60 plus root 15 minus square root of 240. So this is will be 2 root 135. 135, I don't know the factor to break it to know 145. So what I advise you to do is just come here, just write 135. 135. Can 2 go in there? No, 2 cannot go. Can 3 go in 1? That 3, some 3 can go. 3 in 13. 3 in 13, that's 3 can go in 12, that's 4. Remember 1. In 15, 3 in 15, that's 5. And you see 45 is not a perfect square. I will do it again. I will use, and 3 can still go. 3 in 45, 3 in 45, that means it will give me 15. 3, that's 15. 15 is not a perfect square, but I've already gotten 2 perfect square here, because when 2 factor go, so this one can give me 9 times 15, and one of them is already perfect square. It's either what you have left is a perfect square, or when you do pair of number 2 factor, it's already giving a perfect square. 3. That means I have a perfect square there. Then this 9 times 15 is a perfect square, because if I still break it forward, I say 3 again, so give me 15, they give me 5, and 5 is not a perfect square. So I have 9, so I can put this one into 9 times 15. Then minus 2, I also have idea now. This one, it can be 4 times 15. You see, 15, it seems to be common. Plus, then root 15 is already here. This is the model. This one, what is going to be the multiple of this one? I don't know. Let me come here. So since I already know that 15 is common, but I can't say, so let's say 240. So let me use 2 in 20. This one is going to give me 120. All right, 2 again, so give me 60. right? So 2 again, it's going to give me 30. 2 again, it's going to give me 15. Now, none of this one is a perfect square, but I've gotten a perfect square here. Why? Because I have two pairs of number. That is 2 pairs of number. So this one will give me 4. This one is also give me 4. So 4 times 4 will give me 16. So I have 16 as a perfect square. I mean 16 times what? Times 15, which is the last number here, is the perfect square. So that's how to simplify it into a perfect square. And if you don't have idea of perfect square to use, break it. Use your factor theorem to check your perfect square. Now with this, I have root 9 is 3. 3 times this one, let's say, give me 6 root 15 minus this 2. 2 times this will be 4 root 15 plus this is root 15. This is 4. That's minus 4 root 15. And if you look at this, I have 6 root 15. So this 15 is common. Root 15 is common, minus 4. Plus this is 1. This is 1. 1. There is nothing there. 1 is only, and I say 1 root 15. That's the meaning. That's minus 4 into root 15 altogether. So 6 minus 4, that's 2. Plus this, that's 3. 3 minus 4. 3 minus 4 is going to give me minus 1 root 15. So that's what we want to do. So people want me to say minus 1, which is the same thing as minus 15. So it's not, or that's to say minus 115, that's minus 15. So that's how about to simplify the sum. Then the last one here, let's see this. Say 3 root 28. Root 28 can be split into 4 times 7. Yeah, 4 times 7 minus 5. This one can be 9 times 7. Right? 9 times 7 will give me 63 plus 4 into what of this one? What is 5? I don't know the factor. So since I don't know the factor, just come to one side here. Write it. So write 1, 1, 2. 2 can go in 1, 1, 2. 2. 2 in 1, then that's 5. Remainder 1 in 12, that's 6. Right? So 56 is not a perfect square. Let's go again. 2 again. 2 in 56. I have 2. Remainder 1. 16, that's 28. Then 2 can go again. 2 in this one. 2 in 28, that's 14. Alright. Then 2 again, that's 7. So see that I have this 6, 2 times 2, 4 times 2, 8 times 2, that's 16. So this one give me 16 times 7. So that's how we get the factor. If you don't know what to do, you can't be guessing, so you have to find a way. So this one, I have root 4. 4 times this, it's going to give me root 4 is 2. 2 times that's 6, root 7 minus 3. Root 9 is 3. 3 times this, that's 15. Root 7 plus 16. Root 16 is 4. 4 times 4, that's 16. Root 7. And this one will give me collect like 10. That's 6 minus 15 plus 16 all together under root 7 common. So the answer for this one, 6 minus this, that's minus 9. Minus 9 plus 16. Or you can see this one minus this one. This one minus that. This one will give you 1. 1 that's under root 7. Root 7. 7 root 7. Give me the answer to the factor. So that's for addition and subtraction of surd. So the next value, the next one is multiply the following: multiplication and expansion of surd. So let's talk about multiplication of surd. When you are multiplying surd, two things have to come to the mind. You have roots of A times root of B. When they are coming together, they are not the same, so just put them under the same umbrella. That's root AB. Another one is also root A. If they are the same, root A times root B, root A times root A can be captured as what? Root A square. And A square, this A times so what? Just give you A. So anytime I see root A times root A, I will just pick one of the letter inside as my answer. So to do that here, this one is root 5 times root B cannot be simplified, so I will capture them. They are not the same. That's 5 times 10. So this one will give me root what? Root 50. And when you have root 50, it can be further simplified. I can use another factor, which is 25 times 2, another multiple to simplify it further. So root 25 is now what? 5 root 2. Right? So this is how you have to operate on this. So for this one, the best way to simplify first, after you have simplified, then you now multiply. Simplify. This one is already simplified. But when I multiply, I have factor. They give me a multiple that can be further simplified. You see? So until you get a simplified value. So this is also another one. So I can simplify this one to root 27 to be root 9 times 3 times this one will be 25 times 2. So if I simplify this one give me 3 root 3 times 5 root 2. Now, if I take the whole number together, so let me pick the whole number together. That means 3 times 5, so put them together. Then the other one, the root together, 3 times 2 under the same root. So if I multiply this one, it gives me 15 root 6. So this is how we go about this. So this can be simplified. This can be simplified as 4 times 3 times 3. Then you break 60. 60, what is the multiple of 60? 60 can be written as 10 times 6, can be written as 30 times 2, but neither of them can be written as 4 times 15. 4 times 15 is the one that can help you. This one also can be written as 9, 9 times 3. 9 times 5, sorry. 9 times 5. So 9 times 5 can be this one. Alright, since this one will give me 2 root 3. If I simplify this one times, this one is give me 2. 2 times 3 will give me 6 root 15 times, this one will give me 3 root 5. But this root 15, I can split it into 2. 2 root 15 root 3, 36 times 6. I can break this one into 2 to be what? 3 times 5. This one will give me 5 roots, because there are 2 pairs of numbers times root 5. So which is 36 times 3 root times 15. 5. So if I collect the whole number together, 2 times 6 give me times 3. So collect the root together. This one I have root 3. I have another root 3 here. That's that. I have root 5 here. For this, there's 2 root 5. So you can see that there's pair of this number of root 5. If I multiply this 3 times 2, that's the 12 root 5 together. Root 5 times root 5. So this one will give me 4 times 5. So this is 20. So the same thing applicable to this one. 2 root 3 times 2 root 3 times 2 root 3. 2 times 2 times 2 will give me 8. Then root 3 times root 3 will give me another 3. Then I have root 3 left. So this one will give me 24 root 3. 24 root 3. So let's take this one as your assignment. Do it and put it on the comment section as the answer. So let me cross check. Thank you for watching. So to avoid the video too long, I will continue from that in another video. Thank you and God bless.